in right ventricular and left ventricular hypertrophy, one very most important crucial thing to be looked at is the axis deviation. So axis deviation. So so there is mnemonics or a simple logic that R for R, it means if there is right ventricular hypertrophy, then axis will be deviated towards right side, and if it is left ventricular hypertrophy, then the axis will be deviated towards left side. So this basic thing you need to keep in mind. Now we'll be discussing how to look at axis deviation in another video, and till then again you can revise what are the criteria for left ventricular hypertrophy. Please go through that, and right ventricular hypertrophy and associated like clinical features to it, such as in case of COPD, cor pulmonale, there can be right ventricular hypertrophy, and features like aortic regurgitation, and so these could lead to left ventricular hypertrophy. So these things you can correlate with the clinical symptoms as well. Basic idea of how to find axis deviation, what I would like to give is that what I usually do is that again let's come to the basics. What I usually do is I take lead 1 and lead AVF generally, and I compare whether lead 1 in lead 1 the resultant QRS complex is positive or negative, and I compare in lead AVF the resultant QRS complex is positive or negative. So let's take one example. Suppose this is lead 1, this is lead 1. In lead 1, suppose I find like this, it's just theoretical, so you see here, okay, so in lead 1 I found like this. So you see here, this is negative Q and this is negative S and this is positive R. However, the resultant QRS will be positive in this case. So resultant QRS is positive because the magnitude will be, this is greater, and when you subtract them or add them all, you will find positive vector. And let's say another example, in case of lead AVF, suppose in lead AVF I find like QRS complex like this again, okay, so again in this case the QRS complex is positive vector, so positive deflection is there. So when I plot them in lead 1, suppose this is of magnitude 4 millivolt, suppose up to here it is 4, isn't it? And in case of lead AVF, it is like, suppose let's say 4.5, and I draw a vector till here. So this is the magnitude I have in lead 1 and this is the magnitude I have in AVF. And now what I do is I draw a perpendicular line to them. So this is one perpendicular line and another perpendicular line to them, and when I make a resultant vector in it, so this is the axis of that QRS complex. So this way I find the axis of the given ECG. So let's take another example. Suppose let's say this is lead 1. In lead 1, and there is, okay, let's say maximum part here it is negative deflection, and in case of AVF, let's take example that it is positive deflection, so it is like this. So again what I do is I draw them up. So this is lead 1 and this is AVF. So you see here in this case, you see lead 1 it is negative deflection, so the vector would be in this direction, so it is negative. So this is our lead 1 vector representation, which is negative, whereas in case of AVF it is positive. So in case of AVF it is positive, so drawing it till here, so it is positive. So again same basic funda, I draw a perpendicular imaginary line, so this would be a perpendicular line, and similarly here it would be your perpendicular line, and when you draw the resultant, so this will be the axis. So you see this axis, it is probably greater than 110 degree, so it is shifted towards the right, and it can be because of right ventricular hypertrophy, or it could be because of right bundle branch block. So uh, basically, right axis deviation can be seen in right ventricular hypertrophy and right bundle branch, and other examples also you can look and study. So you see here, by this simple logic, you can find the axis of a given ECG and tell whether it is deviated towards right or left. Thank you.